Dear students, welcome back my channel. Today I have taken some question from a past paper today. I am going to explain that questions. Not much explanation. All the explanation already I have given. So just you understand what type of the questions also come from the nucleophilic substitution reaction. First question you will see, name the instrument used for measuring angle by which the plane polarized light is rotated. Name the instrument. They are asking name the instrument. You know that the optical activity, you know any one of the molecules, that is a chiral molecule, A. Then it will be shows that the mirror image. So this will be this is optical active compounds. It will be either rotate the anti-clockwise or clockwise rotation. So this is the rotation we can calculate it by polarimeter. Name the instrument used. Name the instrument. That is a polarimeter. Page number 175. It is in the answer, page number 175. Then the second question, enantiomers. Enantiomers also already I explained to you. That is non-superimposable. Not superimposable means, for example, you consider this the molecule. When you take this molecule and keep here means it is the not impossible. Like our hand, like this. இப்படி இருக்கும். இப்போ இந்த மாதிரி இருக்கும். இது எப்படி எங்க வச்சோம்னா நான் சூப்பர் இம்போசிபிள். இதெல்லாம் வந்து என்ன சொல்லுவோம்னா ஆப்டிக்கல் ஆக்டிவ் மாலிகூல்ஸ். ஸோ தட் இஸ் இந்த ரெண்டு மாலிகூல்ஸும் இந்த ரெண்டு மாலிகூல்ஸ் என்ன சொல்றோம்னா enantiomer நான் சூப்பர் இம்போசிபிள் மிரர் இமேஜ். பேஜ் நம்பர் 177. The next question, out of chlorobenzene and cyclohexyl chloride, which one is more reactive? Nucleophilic substitution reaction and why? Nucleophilics, out of chlorobenzene, then the cyclohexyl chloride, which one is more reactive? Nucleophilic substitution reaction. Here, which one is more reactive? The cyclohexyl chloride is a more reactive. The reason, resonance and sp2 hybridization. The resonance and sp2 hybridization. Chlorobenzene, the structure, you know that. This is the double bond. So sp2 hybridization, due to this sp2 hybridization, also the resonance, chlorobenzene is less than more non-reactive or less reactive than cyclohexyl chloride. Then the next question, fourth question, out of chlorobenzene and benzyl chloride, which one get easily hydrolyzed by aqueous sodium hydroxide and why? First of all, you know the structure. This is the chlorobenzene. Another one is the benzyl chloride. Here you see, this is the same reason. Already I explained that due to the resonance effect, sp2 hybridization, it is non-reactive. But here, this is a benzyl chloride. It is from the benzyl cation. This benzyl chloride is the high stability. So this is from the carbocation. So it is from the carbocation. So benzyl chloride is highly reactive with aqueous sodium hydroxide. Then the next question you see, identify the chiral molecules. Identify the chiral molecules. Just before I explain that, is the molecule which shows the optical active, that is known as the chiral molecules. The first compound you see, first compound, carbon, hydrogen, then Cl, CH3, then C2H5. C2H5. This carbon is satisfied with the different groups. This carbon is satisfied its valency, the different groups. Here methyl, ethyl, chlorine and hydrogen. And the second group you see, second group C, hydrogen, Cl, C2H5, C2H5. This carbon, it is not satisfied the different group because the hydrogen is the same group. So this group is a chiral carbon atom present group. So this is a chiral means the carbon which is satisfied its valency with the different groups, with the difference group, that is a chiral. Then the next one, a racemic mixture is optically inactive. Why? Racemic mixture. First you understand what is the racemic mixture. The racemic mixture means, already I told you, this is some compound, it will be the optically active compound. Optically active compound, it will be either clockwise rotation or anti-clockwise rotation. The clockwise rotation, we will see the Devo rotatory, anti-clockwise levo rotatory. The racemic mixture means this is a mixture containing this is a 50% of levo configuration compound, this is a 50% of dextra rotatory compound. So the 50 plus 50. So when you are pass the light through the racemic mixture, this both will be happen. This is 50%, it is the rotate the right side, 50% rotate the left side. So the net rotation is a 0. Net rotation is a 0. So racemic mixture is optically inactive. Then what are ambidentate ligands? What are ambidentate ligands? This ambidentate ligands, it is in the page number 170. The page number 170, ambidentate ligand, that means actually example, first I write the example CN, NO2, these are the ambidentate ligand. This ambidentate ligand means here is the carbon and the nitrogen is there, here is the nitrogen and the oxygen. These are both are the atom, carbon as well as nitrogen, the tendency to bond with the reactants. That means the suppose for example we will react it to the RCl plus KCN. Now you see here the bond between the RCN, alkyl cyanide. At the same time, instead of KCN, you are added to the AgCN. RCl plus AgCN. RNC. I hope you can understand. You see, this is a carbon cyanide. The both has the ability to bond with the reagent, the reactant. For example, first set KCN apply பண்ணும்போது, this is a cyanide. The C, it is bonded to the alkyl group. When you are added to the AgCN, when you are added to the AgCN, N it is bonded to the alkyl group. So tendency to make the bond either carbon and nitrogen. ரெண்டுமே tendency இருக்கும். That is the ambidentate ligands. Page number 170. It is the answer. The next question, the presence of the NO2 at ortho and para position increase the reactivity of the haloarenes. Why? Ortho and, for example, the chlorobenzene, first I will draw. Chlorobenzene, ortho position NO2, then the para position NO2. Now you see, NO2 is a electron withdrawing groups. NO2 is a electron withdrawing groups. So this NO2 attract the electron towards itself from the benzene ring. So this group are highly reactive towards nucleophilic substitution reaction. Thank you, students. Next class I will bring some other questions from past paper. Then the next chapter. Thank you.